today we will discuss base 8 or octal number system. Now, if you write down the octal number system, we are talking about the base 8 number system. That means not base 10, not base 2, but base 8. Why do we do that? I will discuss that with you all in a little bit. So base 8, that means we can write our digits up to 7 as single digits, but whenever we count to 8, we have to write down 1 0. That means one full group of 8 and no more, right? Just like before. So here we can start down. So if I am counting 1, 2, 3, 4, 5, 6, 7, 8, let's make 2 here, 9, 10. So I group them first 1, 2, 3, 4, 5, 6, 7, 8, right? This made one full group of 8, and that's how we represent it, one full group of the base, that 8, and then these two can be written as single individuals together. If I add these together, I get a 12. So 10 in base 10 is basically 12 in base 8 or octal number system. What that means is we have one full group of 8 and 2 more, okay, like we did before. So an octal number system is pretty interesting. We can use digits from, like I said, from 0 to 7. Okay. Now, if you go back and think about the digits that we have in octal number system are 1, 2, 3, 4, 5, 6, and 7. So the 0 can be represented as 3 bits of zeros. Why am I saying the largest number that we have is 7, which can be represented as 3 bits? 1, 1, 1, right? As 3 bits. This is nothing. 1, 1, 1. How? Because if you write 1, a 1, and a 1, so that would be 2 to the power 0, 2 to the power 1, and 2 to the power 2. Just like we discussed in the binary conversion, that will be 4 plus 2 plus 1 is equal to 7. So here we have the octal numbers. So since the largest one takes 3 bits and some of the smaller one will also take 3 bits, we will just use 3 bits to represent any of our octal numbers. So these are the binary representations of our octal digits, okay? Here we go, and 6 is 1, 1, 0, and 7 is 1, 1, 1. Now, so what you can do is, for example, I wrote down 234 base 8, right? So what it would be, first as a reminder, what it would be, if we have to convert into decimal, we will say 2 multiplied by 8 to the power something, 3 multiplied by 8 to the power something. We will come back to the powers later on. 4 multiplied by 8 to the power something. So starting from there, 8 to the power 0, 1, and 2, right? The placeholder values will tell you that, and that multiplied by this digit. So 8 to the power 0 is 1, multiplied by 4 would be 4. 8 to the power 1 is 8, multiplied by 3. 8 times 3 is 24. 8 square is 2. Okay. 8 square is 64. 64 times 2 is 128. So the number 234 can be represented as 234 base 8 is 128 plus 24. So write down, add them together, 128, 24, and 4. 4 plus 4 plus 4 is 16, 1 carry, that will be 5, 156. So 234 base 8 is equal to 156 base 10, right? Now, why do we even use octal numbers? So let's say, think about it. If we have a very large number, a very large binary number, as you can see, since we have a very small grouping, the binary numbers get pretty large pretty quickly. and to remember them, to write them, and to kind of like kind of make sure that we are copying them from one place to another. It's very hard to remember this such a long string. So what we do is we divide it up into groups of threes, as I'm doing in here, groups of threes, groups of threes. Now this guy does not have 3, so we will just add 2 extra 0. As you guys know that on the adding zeros on the left hand side doesn't change the number. For example, if I have 100 and I added 2 zeros in it, that will not affect its value. So then we will say 110. What would be that octal digit? That would be a 6. How? We will take 110, we will put 2 to the power 0, 2 to the power 1, 2 to the power 2 here, 4 plus 2 plus 0 is equal to 6. Similarly, this will be 4, this is 1, this is 3, this is 6 and 1. So this long string 0 0 1 1 1 0 0 1 1 0 0 1 1 0 0 1 1 0 base 2 can be written in a somewhat shorter form 163146 base 8. Now what is the advantage of it? Because we can take this number any time, and taking one octal digit at a time, we can expand it back into its binary form. So let's take a look here. So you have 163146, right? Base 8. You start expanding from this digit. So 6 will be expanded to, as we know, 6 is 110, 4 is 100, 1 is 001, 3 is 011, 6 is 110, and 1 is 001. We can ignore these leading zeros, but that is what we get back after we expand it. So octal number system is used, actually it has its own significance, but it is used to express long binary digits into a somewhat shorter form, and it is easily expandable as needed. So that is why we use the octal number system. So I hope you understand this. So we can very easily go from octal to decimal, decimal to octal. So if I have a decimal number 1 to 1000, so let's say 123, and I want this is base 10, and I want to convert it to a base 8 number, and what would that be? So what I would do is I will use my old trick of converting any base. I take this, I divide it by my base. In 12, how many times it goes? 1 time. 4 goes in here, that would be 15, but there is a leftover of 3. I will keep that leftover. Then I divide again. How many times does 8 go in here? Only once, and then there is a leftover of 17, right? Starting from here and going up like this, we will take the digits. So 123 base 10 is equal to 173 base 8. Now what we can do is, if you have to convert 123, so we can take 123 base 10, that's equal to 173 base 8. Oh sorry, okay, I made a mistake, let me erase that. It's 173. Let me go. 173 base 8, right? Now I can, now if I have to convert 123 base 10 to its binary friend, or its binary, I can go 2 ways. Either I can take 123 and divide it by, so let's do the old-fashioned way, or our regular way, or it's not old-fashioned, it's just regular. So let's do that 6 times and then 1. I have a remainder of 1 here. So let's do it again. We do that 3 times and then 0 time with the remainder of 1. 2, 15, remainder of 0, 2, 7, a remainder of 1. Let's continue. And then we take it, and then we take 2 divided by again, it goes 3 times with the remainder of 1. We divide it back again, it goes in there 1 time with the remainder of 1. So starting from here and going up like this, we get the number that is our binary number, which would be 111011, right? 111011. This is base 2. Now on the other hand, if you remember, I have converted it and I had 173 base 8, right? Now expand this into its binary format. So we know 3 is 0, 1, 1. It just, you either have to memorize these or just simple conversion. 7 is 1, 1, 1, and 1 is just 0, 0, 1. Ignoring these, isn't that the same number? Well, I have I forgot 1 1 in here. This one, 1 2 3, there should be 4 ones, so I made a mistake in here. But you see, either by dividing it by this and converting into a binary number, or taking your first converting into an octal number and then expanding that octal number to get the binary one, it's good. Either way, it is fine. So depending on that, this is something that we should know, the relationship between the octal and the binary numbers and the decimal number. All the bases are interconnected. You can go from octal to decimal to binary, from binary to octal to decimal, whichever way you want to go.